Hello. Welcome to the first virtual lesson that I'm giving this year. Sorry, my hair is a little crazy. This is on powers of 10. So we're going to go back and talk a little bit about what a power of 10 is, and then we're going to talk about multiplying and dividing by powers of 10, and we're going to look for patterns. So you are familiar with this. From kindergarten on, this represents 1. So this is, if you have 10 of these, you have 10 ones. That is the same as one of these, 10. This is 1, 10, 10 stick, okay? And if you have 10 of these, you have 100. Now, I've done a lot of this with filling in the hundreds charts. And so I think everyone's familiar with this. So we go from a 1 to a 10 to 100. And then if I stack 10 of these up, 10 100s equals 1,000. So we have our handy dandy place value chart that I gave y'all inside your sheet protector. And we're going to make much use of this over the next few weeks and throughout the year. So if you'll look, we have ones place, tens place, hundreds place, thousands, and then it goes up to millions. Now, what might be new, especially since we had digital learning toward the end of the year in 4th grade, is this part down here. That big old period right there isn't a period, it's a decimal. And decimals should look familiar just because everyone deals with money, and there's decimal points in money. But we are going to go over what a tenth, a hundredth, and a thousandth is. So if we have one of these little pieces, and this represents 1, if I were to cut this in 10 pieces, one of those little pieces would be a tenth. And if I were to cut that little tenth into 10 pieces, I would make it 10 times smaller, and that would be a hundredth. Okay, we're pretty familiar with tenths and hundredths because a tenth is a dime and a hundredth is a penny, because it takes 100 pennies to make $1. Okay, so if you look, each one of these, as we go to the right, it gets 10 times bigger. So it takes 10 ones to make 110. It takes 10 tens to make 100. So it's times 10, times 10, times 10 each time we go one place value to the right. Now, if we go place values to the left, that's divided by 10. Because if we have a $10 bill, we could divide that by 10 and we would get 10 $1 bills. So $1 is 10 times less than $10. All right. So that's just a brief intro to place value. And you already took notes on it in your journal. So as you move this way up, you get 10 times higher, 10 times higher, 10 times higher, 10 times greater. Each time you go one place value greater, one place value to the left. As you move down the chart to the right, you get one place value to the right equals 10 times less. Okay, so let's look at a few numbers. If I had the number 12, that is 110 and 2 ones. Okay, so let's say that I have a dozen donuts. Yes, that's my jam. So if I had a dozen donuts and I were to go out and just go crazy and buy 10 boxes of these dozen, each box has a dozen donuts in it. So I was going to buy 10 boxes of those. That would be 12 donuts times 10. So 12 times 10. Now, if you know your fast facts, then you know that's 120. But let's look and see what that actually looks like. So if I were going to buy 10 boxes of a dozen donuts, I would have 120 donuts. All right. Now, let's say I'm going to go crazy even more. Let's say it's my birthday and I just want to shower my students with donuts. let's say I buy 100 boxes with 12 donuts in them each. Okay. I'm going to have 12 times 10 times another 10 because 100 is just 10 times 10. So my answer is going to end up being 1,200 donuts. I think we can start to notice a pattern here. Each time we multiply by 10 again, I'm shifting one place value greater, and I'm going to have to hold the place somehow. I can't just write it like this. I can't write it like that. I got to fill in that blank spot with a 0. Okay, so those zeros are called our placeholders. So we're going to shift everything one place value to the left, and we are going to fill in with zeros. So what happens if I win the lottery and I buy 10,000 boxes of donuts? 10,000 boxes of donuts. Well, 10,000 is 10 times 10 times 10 times 10. So that's 4 tenths. So each time I multiply by 10, I'm going to shift it over one place value greater. So I'm going to multiply it, and I'm going to go all the way over here. And I'm going to have to shift that 4 digits to the left. And then I'm going to fill in those blanks with zeros. Okay? So if you look, we can come up with a pattern. Now, sometimes people say that you add zeros to the end, but we don't do it that way. The real reason is because every time, that doesn't work with decimals. So let me show you what I mean by that. Let's say I'm gonna throw a party, and I want to see how much food I can buy. Let's say I want people to contribute $3.50. I have $3.50 here. Okay. Now, I want to know how much food I can buy with this. So if I'm the only one giving money, then I can't really buy that much food. But what if I get 10 people to contribute $3.50? So $3.50 times 10. Now I'm multiplying by 10, which we know now, hopefully, means we're going to shift the place value over. Each of our numbers is going to shift greater one place value. So I can scoot my 3 over 1 to 1 digit. I can scoot my 5 over 1 digit, and I can scoot my 0 over 1 digit. See how I just scooted everything over one time to the greater side? Sorry, my head's backwards. So if 10 people contribute $3.50, then I can have $35 to spend. Now, I can do a few pizzas with that, and that's nice. But what if I want more than that? Let's say I get 100 people to contribute $3.50. Well, $3.50 times 100. 100 is just 10 times 10. And I know that because I see that there's no decimal and there's 2 zeros right here. That means I've had 10 multiplied together twice. That means I'm going to, from my original 350, I'm going to scoot my 3 over 2 place values. So my 3 is going to end up right there. I'm going to scoot everything over 2 times. All right. And I have $350 now. Now, let's say I get 10 times more people. We got 1,000 people donating $3.50. That means from my original number, my 350, 1,000 is just 10 times 10 times 10. I'm looking at those 3 zeros. So I need to scoot where my 3 was originally. I need to scoot it up greater 3 times, 3 place values. So let me do that. Okay, so now I have a number that looks kind of weird because it really just looks like 350 with a kind of a hole in the end. So what I'm going to do is I've got to fill that in, and I'm going to do it with a 0. It's going to be my placeholder. $3,500. Yeah, I will take that. That is a party. All right. So as we multiply by 10, we're going to shift things over greater one place value. Okay. Now let me throw one more thing at you. I'm going to give you two numbers. Okay. I'm going to give you 50,000 and 50. Okay. I want to know how much bigger 50,000 is than 50. Now, you're going to know that these two are related and that they're some power of 10 bigger than each other because we have a 5 and a 0 on the bottom, and on the top we have a 5 and just more zeros. So that means it's times 10 or times 1,000 or times something that's like that, okay? Now, we can tell this pretty easily if we will use this chart. This chart makes things so much easier. You're welcome. Okay, my 5 right here, all I have to do to figure out how much bigger this one is on top is see how many times 10s it takes to get this 5 here, okay? So times 10 once, times 10 twice, times 10 3 times, okay? So what is 10 times 10 times 10? Well, 10 times 10 is 100, times 10 again is 1,000. And I know if I write it, it should have 3 zeros there because that's 10, 100, 1,000 times 3, okay? So I know that 50,000 is 1,000 times bigger than 50. And I can know that for sure because if I place them just like this on my place value chart and line them up in their place value, then I can just count 1, 2, 3 times over, and that's 1,000. All right. So if you still have questions, or if you'd like to go over the dividing part of this, then hit me up on one of the workshops. Okay. I can't wait to work with you guys. All of the other optional activities are good. So if you got any questions, let me know. Otherwise, I will see you at a workshop. Thank you.